Hello everyone, welcome back to another video. Today we will be talking about factoring and distribution and how those two relate to each other. So distribution is usually the easier of the two to do. So we'll start off with the distribution. So let's start off with x plus 2 times x plus 3. Now most of you have learned the FOIL method, which is first, out, in, last. But this doesn't really explain how the distribution process really works. So what I like to do is I like to take this whole thing and distribute it to the x and the 3. So we get x plus 2, and we have the x in the first one, and then the second one is plus x plus 2, and we have the 3 from the second one. So that's our first distribution. I'll call that 1. And then our second distribution is going to be x to x, x to 2, and then 3 to x, and 3 to 2. So x and x gives us x squared, x and 2 gives us plus 2x, the 3 and the x gives us a plus 3x, and the 3 and the 2 gives us a plus 6. So this is our second distribution here. And then we just combine like terms. So we get x squared plus 5x plus 6. So the distribution is straightforward. So let's go to the factoring now. We'll take the same equation, x squared plus 5x plus 6, and now we will try to factor this out. So how do we do factoring? Well, we can think of there being a 1 here if we're thinking ax squared plus bx plus c as a quadratic form. So a is 1, b is 5, and c is 6. So how do we solve this? Well, we want to see what a times c is. A times c is, in our case, a is 1 and c is 6. So 1 times 6 is 6. So we want to see which two numbers multiply to get 6, and which of the same two numbers add to get our b, which is 5. And I'll just write a b over here because our b is 5, this right here. So our b is 5 and our a times c is 6. So which two numbers multiply to get 6 and add to get 5? You'll eventually see that it is 2 and 3. 2 times 3 is 6, and 2 plus 3 is 5. So we can split this up into 2x and 3x, because we found the 2 and the 3. That gives us the 2x and the 3x. So then we can rewrite it. So we will rewrite this as x squared. I'm going to leave out the 1 because it's just 1 times x squared, which is just x squared. And then we have a plus 2x and a plus 3x and a plus 6. So this is similar to our second distribution. So this is our first split. So this is similar to 2 because we're going backwards. And the next step is to see what is common in the first two terms. Well, we can take out an x as common. So x times x gives us the x squared, and x plus 2 gives us the 2x. And then we look at the next two terms. What can we take out of 3x and 6? We can take out a 3, so plus 3, and we get x plus 2. Now we know we did this correctly if the stuff inside the parentheses is the same. So since it's the same, that's kind of our check to see if we did it correctly. So we know one term is x plus 2, and then we are left over with the x plus 3. And this was kind of our first part over here. From here, we just did that part backwards. We just took out an x and it took out a 3. And that was the taking out the x and taking out the 3. So we just did both of those steps backwards. So as a general example, we want ax squared plus bx plus c for factoring. So these are the steps for factoring. We want our quadratic to be in that form. Then we want to see what two numbers multiply to get a times c, and what same two numbers add to get b. So that's our first step. Then we rewrite our equation, rewrite it all out, don't combine any terms, rewrite and don't combine. And then the next step is to look at what can be taken out from the first two terms, and then take that out. And then after that, we look at what can be taken out from the second two terms. And then after that, if the stuff in the parentheses is the same, then we know we did it correctly. So if the stuff in the parentheses is the same, it is correct. So let's look at another example. Let's look at a more complicated example. We'll do 2x plus 1, and we'll do a x minus 3. So if we distribute this, x plus 1 to the x and x plus 1 to the negative 3, we get 2x, or rather 2x plus 1 to the x and 2x plus 1 to the negative 3. We get 2x plus 1, and that gets multiplied by x, and then the plus 2x plus 1 and multiplied by negative 3. So that's our first distribution, and then our second distribution is x to the 2x and x to the 1. This gives us a 2x squared plus x, and then the negative 3 to the 2x and a negative 3 to the 1. So this gives us a negative 6x minus 3. And then we just combine the like terms, and we get 2x squared minus 5x minus 3. So let's take that same one, 2x squared minus 5x minus 3, and let's do the previous thing we did. What two numbers multiply to get a times c? And we have a is 2 and c is negative 3. So our a times c is negative 6. So what two numbers multiply to get negative 6, and those same numbers add to get our b? And our b is negative 5. This is our b. So what two numbers multiply to get negative 6, but add to get negative 5? Eventually you will see that it is negative 6 times 1 and negative 6 plus 1. Negative 6 times 1 is negative 6, and negative 6 plus 1 is negative 5, which is our b. So next we rewrite our problem out. 2x squared minus 6x plus 1x, or we can just write x. I'll just leave the 1 out. Or actually, I'll leave the 1 in. So plus 1x and then minus 3. So then we look at the first two, 2x squared and negative 6x. What can we take out? We can take out a 2x, and we're left with x minus 3. And then what can we take out from here? Well, we can take out a plus 1, x minus 3. Usually, in the past, we wouldn't do this, but we want the inside of the parentheses to be the same. So that's why we have to take out that plus 1. Even though if we leave it blank, it's still correct, we want this plus 1, and you'll see why later. So x minus 3 in parentheses is the same, so then we can do x minus 3 in parentheses as our first term, and then our second term is whatever's left over, 2x and plus 1, 2x plus 1, and this is why the plus 1 becomes important to write, so we can see that we've taken out a plus 1. If we hadn't done the plus 1, then it might have been more difficult to see. And you'll see that the 2x plus 1 matches up here from our original, and then the x minus 3 also matches up here with the original. And hopefully this will show you how we can take distribution and factoring and how these work together. This will work with anything that can be factored, And in the next video, I'll show you some shortcuts for some special cases. Hope this helps.